Okay, people, welcome back to the next lesson, lesson 2 on section properties. I'm taking it from the same document as in Applied Mechanics, or well, was one of them. It's over there, okay. And of course, the question is determine the position of the centroid. That means where the x and the y axis meet, okay. Right over there, and then also calculate ix and iyy, rx, ryy, zxx and zyy. Okay, so the same thing like we did for the first section, we have to do this for the second section. Okay, right, people. So to work at position of centroid, I am going to work around that point there. Right, so right, let's see. I'm gonna make this bluey stuff. Okay, right. So I'm gonna say if I'm working with this point here, that means the distance. So I'm gonna do bar y first, okay? But I'm gonna work from here, so that means I'm gonna be able to calculate y bottom first. Okay. If I'm working from that point down, I'm going to get y top first, but I'm working from there, so I'm going to get y bottom first, and then calculate y top, and then I'm going to calculate x left, and then work at x right. Sorry, let me say that again. If I'm working about this point, I'm going to get y bottom first, and then calculate y top from the full depth, and then I'm going to calculate x left, determine x left, and then work at x right from the full width of the section. So that there is equal to the area, multiply that over the total area. Right. I'm going to divide this into sections that I know from the table I gave you. I'm not going to show it anymore because you know what table I'm talking about. No, I don't want to do that. I want to go that, and I'll make that there. So I'm going to divide it into triangle, and I'm going to call, okay, and then that there is going to be my semicircle like so, and I'm gonna draw each axis with a similar semicircle there. Right, so so my triangle, I'm gonna make that element 1. I'm going to make my rectangle element 2, and I'm going to make my semicircle element 3. Okay. And the centroid for the triangle will be sitting somewhere over there. And the centroid for the semicircle will be sitting somewhere over there. And the centroid for, let me make it nice, for the rectangle will be sitting somewhere over, I think, says over there. Okay, right. Let's do this. At element 1, triangle, half base times height, half times base. Sorry, I forgot the dimension for that and there, which I should have done immediately. If that's 120, that's 200 minus, so that base of the triangle is 80. Okay, so the dimensions of my triangle is 100 by 80. So it's half base times height multiplied by y. What's y? Y is distance from the centroid to the line we're taking moments about. So it's 1/3 of 100. Okay, so it's 100. Let me see, it's 100 over 1/3. It's 33.33. Yep, 33.33. The distance from there to there is 1/3 of that. Plus. Why plus? Because it's the sum of, right? Element number 2. The area is 120 times 100. 120 times 100 times. What's y? Y is the distance from the centroid down to the point we're taking moments about, which is half of that, which is 50. Right, semicircle, it's a void, so it is minus, minus, minus. Did you get it? Minus. Okay. Minus. Any void you treat as minus. Okay. What's the area of a semicircle? It's half pi r square. Half pi times the radius squared, which is 40, times. Right. What's y? Y is the distance from the centroid of the semicircle down to that over there. And what's the formula for the distance from there to there? From the table, it is 4r over 3 pi. Okay. And I'm going to work it out quickly. It's 4r over 3 pi. And that is 16.98 millimeters. I'm going to just write it there. So I know that it's there somewhere. Okay, 16.98 millimeters. 4r over 3 pi is equal to that. Okay, so y for my semicircle is 16.98. 16.98 divided by the total area of my cross section. So it is half 80 times 100, half times 80 times 100, plus 120 times 100, which is actually that there, okay, minus, don't forget the minus, if you add it, it's going to be wrong, okay, and the area of the semicircle is minus half pi r squared, minus half pi times 40 squared. Okay, work at the answer, and of course, it must be in millimeters. If you leave the millimeters out, I take a mark off because I'm feeling happy. Okay, it's the distance, so therefore, and all dimensions are in millimeters, so it's millimeters, right? Work at the answer and check yours against mine. And what did you get? I got 51.21 millimeters. Okay, so it's 51.21 millimeters. Okay, and what does that actually mean? That means that the distance from the bottom there distance from there to the x-axis means there that y bottom is equal to 51 point 51.21 millimeters. Okay, and therefore immediately what's y top equal to? Y top is equal to the full depth of the section minus the one we just found. So I'm going to say minus 100 is equal to 48.79. Okay, so y top is equal to 48.79. Okay, there we go. 48.79. 48.79 millimeters. There we go. Right. Now we need to work out how far the y-axis is from here, which will be x left. And of course, once we find x left, x right will be equal to the full width of the section, which is 200. Take away x left, will give us x right. Okay. Right, so let's do that. Right, as I said, we are going to work from this way here. So the first thing we're going to determine is x left. So x left is equal to the sum of all the area multiplied by the horizontal distance over the total area A. Right, I'm doing a triangle, half base some side, of times 80 times 100 multiplied by x. What's x? X is the distance from the centroid of the element to the point we're taking moments about. So from there to there is 1/3 of 80, but from there to there is 2/3 of 80. So it is 80 times 2 divided by 3. It is equal to 53.33. If you make it 1/3, it will be wrong. Plus area of element 2 is 120 times 100. 120 times 100 times, what's x? X is the distance from the centroid of the element all the way to the line we're taking moments about. So it is 60 plus 80. Ne? Half of, if that's 120, so that will be 60 there. 60 plus 80. What's 60 plus 80? It's 140. minus. Why minus? Because it's a void. And the area is half pi r squared times 40 squared. Right, times the distance. What's x for the semicircle? It's the distance from there all the way to there. And that's easy, ne? It's 100 plus 40, so it's 140. And notice there, the centroid of the rectangle and the centroid of the circle just happens to be on the same vertical line, ne? Just happens to be. Right, divided by the total area. And the total area I got there, I'm going to record it there. I'm not going to work it out again. 13486 is equal to, right, and get the distance in millimeters, do the calculation, and check your calculation against mine. And the answer I get is 114.29. Check my answer against your answer. Okay. So therefore, x right is equal to the full width of the section, which is 200. Take it away from there, and you get 85.71. 85.71 millimeters. There we go. And I'm going to assume I fill it in like it should. Okay. So I'm going to draw that line down there like so. And I'm going to draw that line down there like so. And I'm going to put the values in. I'm going to make my arrows like this, the lazy way, ne? The lazy way. Alright, so x left is equal to 114.29, and x right is equal to 85.71. Okay, right, people. So if we go back to the question, we've answered the first question there. And if I go back to my 51.2, 114.3, there we go. So it's correct. Okay, it's correct. Some of you last year, I think those of you working, and you got the answers, and you said, sir, but I get other answers. Yes, you can. Okay. When you have an asymmetrical section like this there, you can get two sets of x bar y's. Why? Because x left, x right. Okay. If you work from that point down there, you're going to get that as a distance and that as a distance. If you work from there, you're going to get x right and y bottom. So can you see here, you can get 3 or 4 pairs of correct answers. So if you work, give me any two, I do all of the calculations to get x, to get y top, y bottom, x left, x right. So if you didn't get these answers there last semester, oops, okay, but you got 85.71 and 48.79, you would have still been correct. Well done if you've done that. Okay, so people, that's over there. So now we need to work out our xx and iyy, the real biggie. Alright, people, our xx. What's the formula for working out the second moment of area using the parallel axis theorem? It is the sum of a square bracket I small x, y small x, because those are the axes of the elements, and that's the x, that's the x axis of the whole cross section, which is that over there, plus the element times the distance squared. Right. I'm doing element 1 first. We have a triangle. A new section. Let me go to the table quickly. Is it there? It's not there. Let me just pull it up quickly. Right, people. We need the second moment of area for a triangle. For the rectangle, we know it is BD cubed over 12. Okay. But for a triangle, and when I said to you earlier in the previous lessons, we are concerned with the top of the 4 triangles. Okay. So second moment of area, there's the column. I'm going down. It is BD cubed over 36. Can you see the difference? Rectangle BD cubed over 12. And the formula for the second moment of area of a triangle is BD cubed over 36. What's B? What's D? B is the side parallel to the axis we take in second moment of area band. So B is 80 and D is 100. Get that right. Okay. So it's 80 times 100 cubed over 36. If you make it 12, it's going to be wrong. Plus A is the area. Half base times height. Half times 80 times 100 times h squared. Are you tuning in? Right. You need to tune in. What's h? H is the distance from the centroid. Okay. It's the distance from the centroid of the element to the centroid of the whole cross section. And if you didn't quite work it out yet, whenever we're working at Ixx, H are vertical distances between parallel, horizontal XX axes. I'll say that again. Are you tuning in? Whenever we work at Ixx, H there is the vertical distances between parallel, horizontal XX axes. So H is the distance from the XX axis of the triangle to the XX axis of the whole cross section. Can we work at it? Yes, we can. So it's y bottom minus that distance over there. Okay? And how far is it from there to there? It's 1/3 of 100. Right, so I'm going to work it out quickly there, and you do the same. It is 51.21. Take away 100 over 3. And I get 17.88. So 17.88. 17.88 squared. Why is it squared? Because the formula says so. Okay. Close the bracket. And then square bracket plus. Why plus? Because it's the sum of. Right. I'm doing the same for element number 2. Right. Ixx rectangle BD cubed over 12. So it's 120 over 100 cubed. 120 times 100 cubed over 12 plus the area. What's 120 times 100? It's 120, 1, 2. That's the area there. Plus. What's h? H is distance from the centroid of the element to the centroid of the whole cross section. So if I draw a line, so there's my XX axis for my rectangle, and h is the distance between the XX axis of the rectangle and the XX axis of the whole cross section. Okay. Now be careful. Just be careful. This is a sketch. We're drawing it freehand. It's not drawn to scale. Okay. That centroid and that centroid could be sitting on the same line, or it could be slightly above or slightly below. Okay. So have a look, think about it, and get the distance h. Did you work it out? Is it sitting on the XX axis or above or below? It is slightly above. Yes, okay. No nonsense. Nonsense, okay. Well, one's above, one's below. Okay, but they're not on the same line. So from there to the XX axis is 48.79, but from there to the centroid is half of that, 50 millimeters. Okay, so the difference between the two is 50 minus 48.79, so it is 1.2. Maybe I should make it that color there. It's 1.21 squared. Okay, very close but not on. Very close but not on. Okay, and then I close the round bracket, close the square bracket, and then I minus a big fat minus. Okay, minus. Right, so because it's a void, so element number 3. Right. What's the formula for the second moment of area of a semicircle? I'm going to my table. Okay, now be very careful. the x-axis of the semicircle is lying this way here, which is parallel to the base of the semicircle. Okay, so if I draw the line in, the x-axis for the semicircle is lying over there like so. That's the x-axis of that semicircle there like so. So the formula for the second moment of area of a semicircle about its x-axis is given by that there. Okay, it's pi d to the fourth over 458. If you work all that out there, it's either that or that, but we're going to use that there because, you know, this is all rounding. You can see it's lots of rounding off. So using that will give you slightly better answer. So it's pi d to the fourth over 458. Okay, so it's pi times d. What's the diameter? Is 80. If you make it 40, it's going to be wrong. It's pi d to the fourth over 458 plus. And notice that people are still plus in the formula, but it's minus there, not minus there. If you make minus there, it'll be wrong. Okay. And then area, what's the area? Is half pi r squared of pi times 40 squared times. What's h? H is the distance from the centroid of the element to the centroid of the whole cross section. Okay. H is the distance from the centroid of the element to the centroid of the whole cross section. Can we work it out? Yes, we can. It's y bottom, take away 16.98. Okay. It's y bottom, so it's 51.21. Take away 16.98, and it's equal to 34.23. 34.23 squared in the formula. Close the round bracket, close the square bracket, and say, wow, now I can eventually work out the answer. Okay, so stop the video, work at the answer, and see that we get the same answers. Right, people, I have gotten, what did I get? I got 1.030. From this point onwards, I'm going to write in scientific notation. You know by now what the difference is between the two. It's 1.030 times 10 to the power 7 millimeters to the fourth. And don't leave the units out. I'll take a marker for that. Okay. Right, people. 1.030 times 10 to the power 7 millimeters to the fourth. So that's our XX. Okay. Right. Let's work out IYY. Right. IYY. Formula for IYY is IYY, big Y is equal to the sum of open square bracket I small y plus AH squared is equal to, alright, element number 1. I just put the 1 there to tell myself I'm busy with element 1. You don't need to put it in, but I find it's good practice. Right, IYY, second moment of area for a triangle is BD cubed over 36. What's B? What's D? B is a side parallel. We're taking second moment of area back. So there's YY axis. So B is 100. So it's 100 times 80 cubed over 36 plus area, half base times side, of 80 times 100 times H. Are you tuning in? What's H? Let me change the color. Let me make it a orangey color, a yellowy one. Okay. H is distance from the centroid of the element to the centroid of the whole cross section. My triangle. H is the distance over there. Did you see that? H is the distance from the center, because the y axis of the triangle sits there. So it's, and notice there, when you're working at IYY, it is the horizontal distances between parallel, vertical, YY axis. Did you get that? I'll say that again. When you're working at IYY, the distance H there is the horizontal distance between parallel, vertical, y-axis. That's the y-axis of the triangle. That's the y-axis of the whole cross-section. Can we work at it? Of course we can. Okay. So from there to there is 2/3 of 80. We take that away from x left and we got the answer. Okay. So let's work it out quickly. And oh man, I didn't want to do that. Alright, okay. Work at the answer and check mine. And I got, what did I get? I got 60.96. Hopefully it's correct. 60.96 squared. And then plus. Okay. Plus. Why plus? Because the sum of, right? I'm busy with element number 2. Okay, the rectangle. Right, second point of area is BD cubed over 12. What's B? So B is 100. So it's 100 times 120 cubed. 100 times 120 cubed over 12. Plus the area. The area is 120 times 100, which is 120 times. Okay. Right, H. What's H? H is distance from the centroid of the element to the centroid of the whole cross-section. Did you get that? H is the distance from the centroid of the element to the centroid of the whole cross-section. And it is equal to x right. Just x right minus 60. Okay, so it's x right, which is 85.71 minus 60. It is 25.71. So it's 25.71 all squared. Close the bracket. And take away, because it's a void. And I'm busy with element number 3. Right. IYY for the semicircle. Very important, very important. I'm going to my table. Now this table doesn't have it. I put it in there. IYY for a semicircle is pi d to the 4th over 128. Okay? You'll have to remember this formula, people. I'm not going to give it to you. You'll have to remember them. So IYY for a semicircle is pi d to the 4th over 128. Okay? So it is pi times d to the 4th over 128 times the area, which is half pi r squared, half pi times 40 squared times h. And what's h? H is the distance from the centroid of the semicircle, which is that, to the centroid of the whole cross section. Okay. H is the distance from the centroid of the element to the centroid of the whole cross section. And we said earlier there that the centroid of the rectangle and the centroid of the semicircle are on the same line. So therefore the H distances is actually going to be the same. 25.71 squared. Okay. Close the bracket and close the square bracket. And work at the answer, yippee. And of course, it's going to be millimeters to the 4th. You stop the video, you work at the answer until we get the same answers. And I got, what did I get? I got 3.595. 3.595 times 10 to the power 7 millimeters to the 4th. Okay. So people, those are all the correct answers because I check them on Procon before I do this, so that when I give you the answers, and if I get that answer that what Procon says, then I know I'm giving the correct answer. So you must get the same answers. Okay, so people, that is the first 2 parts done for that question. Okay, the rest is just Daniel because we're using the I values and the areas and the Y top, Y bottom, X left, X right is easy from here. Okay, so yes, I'm gonna try and squeeze it all in onto the next one and finish it off there. Okay, right, so then part C of this, okay, so Rxx is equal to Ixx over the total area, the square root of the lot, is equal to Ixx, which is 1.030, 1.030 times 10 to the power 7 over the total area. The total area was 13486, 13486.73, the square root of the lot, and the answer I get there is check your calculation against my calculation, and the answer I get for Rxx is 27.62 millimeters. Okay, 27.62 millimeters. If you leave the units out, I'll take marks off. Okay, we're not making cake, we are civil engineers. Okay, right, RYY, big Y, is equal to the square root of IYY over the total area, which is equal to IYY is 3.595, 3.595 divided by times 10 to the power 7 over the total area, which is 13,486.73, and I get, for that I get 51.63 millimeters, because it's a straight distance. Okay, right, part D, ZXX, but I'm going to do Y top first, is equal to Ixx over Y top, which is equal to 1 point, I'm just copying it from there, 3 times 10 to the power 7 over Y top, which is 48.79, 48.79, and that's equal to that. And I'm going to give the answer in scientific notation. So it is 1.030 exponent 7 divided by 48.79. It is 2.11. It is 2.11 times 10 to the power 5. Oh, man. 5. And it is millimeters. It's a volumetric dimension, but it is not a volume. Okay, and of course ZXX, more specifically for Y bottom, is equal to alright, you can finish this off yourself. Okay, you can put the values in there. Ixx is that, Y bottom is 51.21, so 1.030 times 10 to the power 7 divided by 51.21 should give you the following: 1.030 exponent 7 divided by 51.21, and I get 2.01 times 10 to the power 5. Finish it off. 1 times 10 to the power 5 millimeters cubed. In an exam, I give you a mark for the formula, a mark for all of that, and for that over there. So that's 3, 6, 9, 12, 15, 18. So for all of that, that will be 18 marks. Okay. So if you just give me the answer, if you just give me a correct answer with no formula, nothing, I can't take it as a correct answer. I want to see the formula. I want to see the correct values, input the answer, and I want to see the answer. Okay, so finish it off. Right, so I'm going to squeeze the other bits inside here. Let me do that. Right, so let me just do this quickly here. Okay, so I'm going to say Z, Y, Y, and more specifically is to do with X left, so it's equal to I, Y, Y, I, Y, Y over X left. I, Y, Y, what's I, Y, Y? I, Y, Y is 3.595, 3.595 times 10 to the power 7 over X left, which is 114.29, and I'm going to get 3.595 exponent 3.5 exponent 7 divided by 114.29, and I get 3.15, so it's 3.15 times 10 to the power 5 millimeters cubed. I'm just squeezing that in here like so, and you can finish it up yourself. So Z, Y, Y, but more specifically to do with X right, is equal to I, Y, Y over X right. It's getting a bit sloppy here. Put in the line, work all the bits out. Okay, so what's I, Y, Y? I, Y, Y is 3.595 times 10 to the power 7 divided by X right. You finish it off, 3.595 exponent 7 divided by 85.71. I get 4.19. It is 4.19 times 10 to the power 5 millimeters cubed. Okay, people, I've answered the whole question. Okay, that's question 2 fully worked out for you. I did all the bits. I did position of the centroid, X, I, Y, Y, R, X, R, I, Y, Z, X, X, Z, Y, Y. Okay, people, there we've done one full question for you. Well, I've done 2 full questions. I'll after this video, I'll give you a set of exercises, but some advice. I'll give you a quick start in some of them, and as far as section properties go, you're now on your own from this point. Okay, people, I shall see you in the next video.